Good morning class. Last lecture we have seen the aromatic amines. Okay, so we have seen aromatic amines and the phenols. Now the third part of that chapter was aromatic acid. So that part will be covered by Dhanwal. Okay, so I have covered phenols and aromatic amines. So remaining part Dhanwal will cover. Now we move to the next chapter, that is the unit number 4, called as Polynuclear Hydrocarbon. The chapter name is Polynuclear Hydrocarbon. So polynuclear hydrocarbons, what are these polynuclear hydrocarbons? So these are uncharged, so they don't have any charge, neither positive charge, they don't have any negative charge, so they are the uncharged. Then lipophilic molecule made up of fuse multiple aromatic rings. So as we know that if the number of benzene rings are more or the fuse rings are more, then that compound it becomes more lipophilic. Okay, so here you can see some examples. So these are benzene rings, they may be in the fuse form. So poly means more, so they consist of more than one benzene ring which are in the fuse conditions. These are the aromatic rings. So what is the definition of polynuclear hydrocarbon? As the name indicates, poly means more nucleus is present. Hydrocarbon means carbon and hydrogen. So these polynuclear hydrocarbons are generally uncharged, so they don't have any positive charge, they don't have any negative charge, so they are the uncharged molecule. As the number of benzene ring or the aromatic rings are more, they are lipophilic. So polynuclear hydrocarbons are uncharged. Second one, they are lipophilic. Okay. Third one, they are present in the fuse form or the fuse form in the aromatic ring. So they are present generally in the fuse form and they consist of more than one benzene ring. So they may consist of two benzene ring, they may consist of three benzene ring. So they may the fuse form or unfused form. So but there may be consist of more than one benzene ring. Okay. So once again I will tell you what is polynuclear hydrocarbons. So these are uncharged lipophilic made up of fused aromatic rings. Hydrocarbon. Okay, so hydro means hydrogen, carbon means carbon. So they generally consist of carbon and hydrogen atoms. त्याच्यामध्ये कुठलाही तुमचा हेट्रो ॲटम्स नायट्रोजन, क्लोरीन, ऑक्सिजन, सल्फर यासारखा कुठलाही ॲटम त्याच्यामध्ये प्रेझेंट नसतो. दे कन्सिस्ट ऑफ ओनली कार्बन अँड हायड्रोजन. दे आर कॉल्ड एज हायड्रोकार्बन्स. They consist of 2, 3 or more ring containing polycyclic molecule, and they are generally in the form of colorless compound. They may be pale yellow, pale green or white color solids. So overall definition of polynuclear hydrocarbon is that the polynuclear hydrocarbon, they are the hydrocarbons. That means they consist of carbon and hydrogen. They consist of more than two benzene rings, fuse multiple aromatic rings. They are lipophilic, they are uncharged molecules. Okay, that is the basic definition for the polynuclear hydrocarbons. The next part, what are the examples of these polynuclear hydrocarbons? So anthracene, where three benzene rings are fused. Phenanthrene, naphthalene, where two benzene rings are fused. These are the five benzene rings are used. Here four benzene rings are used. Here seven benzene rings are used. So here the fuse of benzene ring takes place. Fusion of benzene ring takes place. So these compounds are primarily found in natural sources like coal, petroleum products. They are generated by the burning garbage, wood, incomplete combustion of fossil fuels, also present in the cigarette smokes. Okay, so this is about the basic information regarding the polynuclear hydrocarbons. So poly means more, so they consist of more than one benzene ring. Okay, it may be the two benzene ring, it may be three, it may be four. They are the fusion form, they are the aromatic rings, and generally they consist of the hydrocarbons. That means they consist of only the hydrogen and carbon. There is no any heteromolecule like nitrogen, oxygen, sulfur, halogen like Cl. It is present. So absent of these heteromolecule, they are uncharged and they are lipophilic. Okay. Next part, the classification of polynuclear hydrocarbons. So polynuclear hydrocarbons, they are divided into two types. One is the benzenoid, second one is the non-benzenoid. So as the name indicates, or you can easily say the definition what is benzenoid or what is non-benzenoid. So benzenoid means which consists of benzene rings, where more than one benzene rings. Such hydrocarbons or the polynuclear hydrocarbon, they are called as benzenoid polynuclear hydrocarbons. If the compound they consist of other aromatic ring than the benzene, so there is absence of benzene, so such aromatic rings or the such polynuclear hydrocarbons, they are called as the non-benzenoid. So this is the example of non-benzenoid. So you can find out here 5 member ring, here 7 member ring, so there is the absence of benzene ring. So azulene is the example of non-benzenoid polynuclear hydrocarbon. Now in case of benzenoid, they are again classified into two types, isolated and fused ring. This is isolated form, so they are different, so they are not fused form. So biphenyl, so two phenyl rings are present which are attached with the bond. So such rings are called as the isolated. Here the fused ring is present when one ring and two rings, they are attached to each other, they are fused to each other. Such polynuclear hydrocarbons, they are called as fused polynuclear hydrocarbons. Naphthalene is the example, phenanthrene is the example. Again these fused, they are classified into two types. One is the linear, second one is the angular. So linear means they are present in the straight form. So here you can say these are in the straight form. Angular means two are straight but third one is the having different angle with the first two, so they are comes under the angular. So in this way the polynuclear hydrocarbons, they are classified. Okay, so polynuclear hydrocarbons, they are classified into two types. One is the benzenoid, second one is the non-benzenoid. So as the name indicates, benzenoid means which consists of benzene ring, non-benzenoid means there is an absence of benzene ring. So example of non-benzenoid is azulene. So here you can clearly observe the structure, there is absence of benzene ring. Okay, the next part, that is the benzenoid, they are classified into two types, isolated and fused ring. Again the fused ring benzenoid polynuclear hydrocarbon, they are classified into linear, second one into the angular. Isolated means they are not in the fused conditions, they are separate from each other. So the biphenyl is the example which comes under the isolated benzenoid polynuclear hydrocarbon. And second one, that is the fused ring, they are classified into two types, linear and angular. So in naphthalene is the example of linear, phenanthrene is the example of angular. So here you can observe they are present in the linear form, in the chain form, in the straight chain. Here this third one is not in the same direction or not in the same position, so it forms an angle with the first two which are in the straight chain form. So due to that, they comes under the second part of the fused ring, that is the angular polynuclear hydrocarbons. So for your syllabus, there are some examples of polynuclear hydrocarbons. For that you have to study their synthesis, then reaction, structure and medical uses. Okay, so for your syllabus there is naphthalene, phenanthrene, anthracene, diphenylamine, triphenyl methane, and their derivatives. So there are some compounds they have given that we have to study in the polynuclear hydrocarbons with respect to their structure, medical uses, synthesis and reactions. So we will start with the first one, or the first polynuclear hydrocarbon, that is the naphthalene. So naphthalene कुठे येतं? This is the naphthalene. So naphthalene comes under the बेन्झोनाइड मधला जो फ्यूज रिंग आहे, फ्यूज रिंग मधला जो लिनियर फॉर्म आहे, त्या लिनियर मध्ये नॅफ्थॅलिन हा कंपाऊंड येतो. सो नॅफ्थॅलिन इज द linear fused ring benzonide polynuclear hydrocarbons. So the first polynuclear hydrocarbon, that is the simplest polynuclear hydrocarbon, which is linear benzenol, as they consist of benzene ring. So this is the structure of naphthalene, which consists of two benzene rings which are fused together. Okay, so this is the simplest polynuclear hydrocarbon. It is white crystalline solid with strong odor. As we have discussed, the polynuclear hydrocarbons, they are generally obtained from the natural sources like coal tar and petroleum. So similarly, these naphthalene also obtained from either coal tar or petroleum by the distillation process. There are different uses of naphthalene. So it is used as dye, plastic lubricants, explosives, सगळ्यांमध्ये याचा use होतो. When high levels of naphthalene vapors are inhaled, it causes nausea, vomiting and headache. So this naphthalene is the simplest one. Two benzene rings are there. This is one ring, this is second ring. So they are fused together. Okay, that's why it is said to be the simplest polynuclear hydrocarbon. Okay. So this is the structure of naphthalene. Two benzene rings are fused. So numbering starts from one of the carbon. You can start from this carbon, or you can start from this carbon. So 1, 2, 3, 4. This is 5. This is 6. This is 7. This is 8. Okay. Then this is 9. This is 10. Okay. So it is 10 carbon containing fused benzene ring. So that is the simplest structure for naphthalene. So in this way you can number, or you can number from this as 1, this as 1, or this as 1. So कुठल्याही याला तुम्ही 1 हा number देऊ शकता, as it is same from if you are given number from any side. This can be 1, this can be 1, this can be 1, or this can be 1. Okay, so that is the naphthalene. So like other polynuclear hydrocarbons, it is obtained from petroleum and coal tar. Okay, we are moving to the next part, that is the chemical reactions of naphthalene. In that, the first reaction is the reduction reaction. Okay, so you can observe the structure of naphthalene. They consist of two benzene rings. That means they consist of double bonds. If double bond is present, okay, suppose this is compound, here double bond is present. If double bond is present, then if we add hydrogen, then the removal of double bond takes place and the hydrogen comes. Okay, so similarly this naphthalene, it consists of two benzene rings. That means it consists of the double bonded structure, and if double bonded structure is present, it the hydrogen can be added. आणि आपण काय म्हणतो हायड्रोजन ॲडिशनला? It is called as reduction reaction. Okay, so naphthalene, first reaction of naphthalene is the reduction reaction. So this naphthalene can be partially, fully reduced under the different reagent कंडिशन. म्हणजे काहीच त्याचे डबल बॉन्ड आपण रिड्यूस करू शकतो, किंवा सगळेच्या सगळे डबल बॉन्ड त्याचे आपण रिड्यूस करू शकतो. सो इन प्रेझेन्स ऑफ सोडियम अँड इथेनॉल इट्स पार्शियल रिडक्शन takes place. So you can observe here they consist of 1, 2, 3, 4, 5 double bonds. So here 1, 2, 3 and 4 double bonds. So one of the double bond is reduced and the addition of hydrogen takes place. Then in presence of sodium and homoamyl alcohol, that is the reducing agent, it is used. It reduces more number of double bonds from the naphthalene. So here only 1, 2 and 3, only 3 double bonds are present. So here 5 double bonds are present, here 4, here 3 double bonds. And when the catalytic hydrogenation takes place, that is in the presence of hydrogen or in the presence of nickel, the complete reduction of naphthalene takes place. So here you can observe there is no double bond, so it is a saturated compound, so it is called as the decalin, as it consists of 10 carbon atoms, it is called as the decalin. In this way the reduction of naphthalene can takes place. So reduction means addition of hydrogen. So when there is a double bond is present, we can form the reduction reaction, that is the we can remove this double bond by addition of the hydrogen. So such reaction is also takes place in case of naphthalene. So please note that in presence of sodium and ethanol, only one bond is reduced. In presence of sodium and homoamyl alcohol, two bonds are reduced. And in presence of catalytic hydrogenation, that is the metal plus hydrogen, like nickel plus hydrogen, the complete reduction of the naphthalene takes place. Here you can observe there is not a single double bond is present in the given structure. So that is the first reaction of naphthalene, that is the reduction reaction. Now the second reaction is the oxidation reaction. So reduction means addition of hydrogen. What do you mean by oxidation? Addition of oxygen. So it may be addition of O2, or you can add only a single oxygen. So the second reaction which takes place is the oxidation reaction. So naphthalene when oxidized under different condition, it gives different products. Okay, so तुम्ही ऑक्सिडायझिंग एजंट चेंज केला तर तुम्हाला जे प्रोडक्ट आहेत ते वेगवेगळे प्रोडक्ट असणारे मिळतात. इथं कसं आहे, रिडक्शनमध्ये पण सेम. H2+ निकेल असेल तर कम्प्लीट रिडक्शन होतं, सोडियम प्लस इथेनॉल असेल तर एक बॉन्ड रिड्यूस होतो. So similarly in case of oxidation also, depending upon the oxidizing agent, the different products can be formed from the naphthalene by the reaction called as oxidation reaction. Okay, so in the naphthalene, if we add oxidizing agent, that is chromium oxide and acetic acid, so we are getting the quinones. Quinones means at the para position two double bond oxygens are present. So such compound is called as the quinone. So it is called as 1,4 naphthoquinone. So this is the structure of naphthalene. This is the first number, this is second, third, this is fourth. So at the fourth number there is oxygen is present, at the first position there is oxygen is present. So 1,4 naphthoquinone, that is the product is formed. So when chromium oxide and acetic acid is used, we are getting the product, that is the 1,4 naphthoquinone. If we have changed the oxidizing agent, if we are using the oxygen in presence of water molecule and zinc, we are getting the aldehyde. So this is the two aldehydes are formed. So this is called as phthalaldehyde. Okay, so what happens, इथून बॉन्ड ब्रेक होतो, इथून बॉन्ड ब्रेक होतो, इथला कार्बन जो आहे आणि इथला कार्बन, त्याच्यापासून तुम्हाला दोन अल्डिहाइड ग्रुप्स आहेत ते मिळतात. सो धिस टेक्स प्लेस इन प्रेझेन्स ऑफ ऑक्सिजन अँड वॉटर मॉलिक्यूल अलॉंग विथ द झिंक. ओके, सो बॉन्ड कुठं ब्रेक होतो, इथून एक बॉन्ड ब्रेक होतो आणि इथून बॉन्ड ब्रेक होतो. सो दुसरे कार्बन आहेत ते दोन निघून जातात. सो इथल्या कार्बनला अल्डिहाइड तयार होते, इथल्या कार्बनला अल्डिहाइड. So compound is called as phthalate. Third one, vanadium pentoxide and oxygen. If we are using the phthalic anhydride is formed. Okay, and finally KMnO4, as we know that it is the oxidizing agent. When KMnO4 is used, similar type of reaction takes place. If KMnO4 is used, what happens if KMnO4 is used? From here and here bond breaking takes place, so cyclic structure is resolved, and we are getting this carbon undergo oxidation to form COH. This carbon also form the COH. So two carboxylic acid groups are attached to the benzene ring. So such structure is called as phthalic acid. So that is the product form when the KMnO4 is used. So this is the second type of reaction, that is the oxidation reaction. So in case of naphthalene, if oxidation agent is chromium oxide and acetic acid, we are getting the product, that is the 1,4 naphthoquinone. If we are using the reagent, that is the oxygen, water molecule and zinc, we are getting the product, that is the phthalaldehyde. If this reagent is used, that is the oxygen and vanadium pentoxide, then we are getting the anhydride, that is the phthalic anhydride. And the KMnO4 and oxygen, that is the oxidizing agent, is used, we are getting the phthalic acid, that is the two carboxylic acid groups. So in this way reduction reaction takes place, oxidation reaction takes place. Now the third reaction, that is halogenation, that is the chlorination reaction, it is the addition of chlorine. Okay, so it also takes place in two ways depending upon the reagent what we are using. So for chlorination we require chlorine. So if we are adding the chlorine, so here and here two chlorines are attached. So the compound form, this is the first position, this is fourth. So 1,4-dichloro 1,4-dihydronaphthalene is formed, or the synthesis takes place. But if we are using the excess of chlorine, so here you can observe all these four positions, four chlorines are formed. So a specific amount we are using the chlorine, this 1,4-dichloro is formed. But if we are using the excess amount of chlorine, so 1, 2, 3, 4 tetrachloro, 1, 2, 3, 4 tetrahydronaphthalene is formed. So depending upon the reagent, so if we are using the chlorine in specific amount, then we are getting the 2-chloro, 1,4 dichloro. If we are using the excess, we are getting the 1, 2, 3, 4 tetrachloro, 1, 2, 3, 4 tetrahydronaphthalene. So that is the third reaction, that is the chlorination. The next reaction is the electrophilic substitution reaction. So as the name indicates, substitution means ह्या नॅफ्थॅलिन मधला कुठला तरी हायड्रोजन जाणार आणि तिथं इलेक्ट्रोफाइल अटॅच होतात. सॉरी, तिथे हायड्रोजन गेलेला आहे, तिथे तिच्या जागी दुसरा कंपाऊंड आहे, तो इलेक्ट्रोफाइल आहे, तो अटॅच होणार. ओके, सो हायड्रोजन निघून झाला की H+ निघून गेला, सो कार्बनवर निगेटिव्ह चार्ज राहतो, सो तिथं दुसरा पॉझिटिव्ह चार्ज येणार आहे. ओके, आता इथं हायड्रोजन आहे, हा हायड्रोजन सपोज निघून गेला, तो निघून जाताना H+ च्या स्वरूपात निघून जातो आणि ह्या कार्बनवर निगेटिव्ह चार्ज येतो. सो हा निगेटिव्ह असेल तर पुढचा येणारा कंपाऊंड हा पॉझिटिव्ह चार्ज असला पाहिजे, तो इलेक्ट्रोफाइल असला पाहिजे. सो इट इज कॉल्ड एज द इलेक्ट्रोफिलिक सबस्टिट्यूशन reaction, that is the removal of hydrogen takes place from naphthalene. So carbon gets negative charge, so another positive charge species bind to this negative charge carbon. So that is the electrophilic substitution reaction. First reaction is the nitration reaction, and we know that the nitration reaction always takes place in presence of concentrated sulfuric acid and concentrated nitric acid. So they are giving the NO2 plus. So इथला हायड्रोजन निघून जातो H plus, कार्बनवर निगेटिव्ह चार्ज येतो, it binds to this position. So we are getting the 1 nitro naphthalene. So concentrated nitric acid, concentrated sulfuric acid, they react together, they produces nitro plus electrophile which binds to the negative charge carbon which is present on the naphthalene. So that is the first electrophilic substitution reaction. Second one, sulfonation reaction. So when it reacts with the concentrated sulfuric acid with temperature 40 degree Celsius, okay, so sulfuric acidचं dissociation कसं होतं, OH minus HO3 plus, so sulfuric acid dissociate as OH minus HSO3 plus. So when sulfuric acid is added, this HSO4 substituted this hydrogen to the carbon. So this HSO3 binds to this carbon. So you are getting this product. So it is called as naphthalene 1 sulfonic acid. So this sulfonation reaction takes place when we are using the temperature at 40 degree Celsius. If we are increasing the temperature up to 180 degree Celsius and we are adding the same concentrated sulfuric acid, then the position of addition of sulfuric acid changes. So sulfonic acid changes. So it binds to the second position, and we are getting the product naphthalene 2 sulfonic acid. So depending upon the temperature, if temperature is less, we are getting the 1 sulfonic acid. If temperature is more, then second reaction takes place, that is this sulfonic acid binds to the second position like this one, and we are getting the naphthalene 2 sulfonic acid. Then next reaction, that is the chlorination reaction. So chlorination reaction takes place in presence of chlorine and ferric chloride. Okay, so Cl2 आहे, it dissociates as Cl minus Cl plus. So हा जो Cl plus आहे, it binds to this carbon and we are getting the 1 chloro-naphthalene. Okay, so that is the chlorination reaction. Next reaction is the Friedel-Crafts acylation reaction. तर तुम्ही जर नाव ऐकलेलं असेल, रिएक्शन बघितले असेल, in the Friedel-Crafts reagent is used AlCl3 along with the acyl chloride in or CS2 we can use. So acyl group COCH3 group, okay, आता CH3 COCl आहे, हे डिसोशिएट कसं होणार, CH3 CO plus Cl minus, Cl निघून गेला in the form of minus, so CH3 CO plus येणार. And this CH3CO plus bind to the this position. So here we can see COCH3. So it is called as 1 acyl naphthalene. And same reaction, if it is takes place in presence of nitrobenzene, this COCH3 group binds to the second position to form the 2 acyl naphthalene. So in this way with the help of different reagents we are getting the different products. These are the electrophilic substitution reaction. Once again I will repeat these electrophilic substitution reaction. Generally what happens, substitution, so here hydrogen is present, sorry, single bonded hydrogen, it is present. So हा हायड्रोजन निघून जातो. हायड्रोजन कशाच्या फॉर्ममध्ये निघून जाणार, इट विल रिमूव्ह इन द फॉर्म ऑफ एच प्लस. ज्यावेळी तो एच प्लसमध्ये निघून जातो, हा जो कार्बन आहे त्याच्यावर निगेटिव्ह चार्ज येतो, सो इट बिकम्स सी मायनस. सो येणारा कंपाऊंड आहे हा पॉझिटिव्ह चार्ज कंपाऊंड असला पाहिजे. सो दॅट पॉझिटिव्ह चार्ज कंपाऊंड कॅन बाइंड टू दिस निगेटिव्ह चार्ज कार्बन. सो पॉझिटिव्ह चार्ज कंपाऊंड म्हणजेच काय, इलेक्ट्रोफाइल. Okay, so in this way the electrophilic substitution reaction takes place, that means removal of H plus takes place, addition of electrophile takes place. So in this reaction it is the nitration reaction, it forms NO2 plus. So ह्या जो कार्बन मध्ये निगेटिव्ह चार्ज आहे तिथे येऊन हा बाइंड होतो. सो वी आर गेटिंग द 1 नायट्रो नॅफ्थॅलिन. दूसरी जी रिएक्शन है सल्फ्यूरिक ॲसिड, इट इज डिपेंडिंग अपॉन द टेम्परेचर. जर टेम्परेचर 40 डिग्री असेल तर हा ग्रुप फर्स्ट पोझिशनला अटॅच येतो. टेम्परेचर जर 180 डिग्री असेल इट बाइंड्स टू द सेकंड पोझिशन. सो दिस रिएक्शन टेक्स प्लेस डिपेंडिंग अपॉन द टेम्परेचर. सो व्हाट हॅपन्स, द सल्फ्यूरिक ॲसिड, okay, it is dissociated as OH minus HSO3 प्लस आणि इथला कार्बनचा निगेटिव्ह, सो इट बाइंड्स टू धिस निगेटिव्हली चार्ज कार्बन. सो इट फॉर्म्स HSO3 दॅट इज द नॅफ्थॅलिन 1 सल्फ्युरिक ॲसिड, किंवा हा कार्बन 2 नंबरचा, इट फॉर्म्स नॅफ्थॅलिन 2 सल्फ्युरिक ॲसिड. सो दॅट इज द second and third reaction, it is called as the sulfonation reaction. Next reaction, that is the chlorination reaction, it generally takes place in the presence of ferric chloride. Okay, so Cl2 is there, it dissociated as Cl minus plus Cl plus. so एकीकडे प्लस असतो एकीकडे मायनस असतो, त्यापैकी जो प्लस वाला आहे तो इथे जो निगेटिव्ह चार्ज कार्बन आहे त्याला बाइंड होतो, आणि वी आर गेटिंग द कंपाउंड दॅट इज द क्लोरो at the first position. So we are getting the product that is the 1 chloro naphthalene. Okay, and remaining 2, that is the acylation reaction, it takes place in different conditions. If it takes place in presence of CCS2, the first position is occupied. If it takes place in the nitrobenzene, the second position is occupied. Okay, so CH3COCl, Cl minus निघून जातो in the form of minus, remaining CH3CO plus is present. This CH3CO plus, it binds to this carbon which having the negative charge, and it forms either 1 acyl naphthalene if we are using the CS2, and if we are using the nitrobenzene we are getting the 2 acyl naphthalene. Okay, so in this way the reactions of naphthalene takes place. First one reduction reaction, second one oxidation, third one chlorination reaction, and fourth one electrophilic substitution reaction. Next part, that is the synthesis of naphthalene, or how the naphthalene synthesized. Okay, so naphthalene is generally synthesized from Howard reaction. So this Howard reaction takes place for the synthesis of naphthalene, and generally naphthalene is obtained from the coal tar or petroleum, which is natural source of naphthalene, but this is the synthetic route of naphthalene. Okay, so the starting material required is the benzene and succinic anhydride. So this reaction takes place, that is the Friedel-Crafts acylation reaction in the presence of aluminum chloride to form this product. In presence of HCl, zinc and mercury, that is the reduction reaction, which is called as Clemmensen reduction reaction. In the Clemmensen reduction means removal of oxygen or addition of hydrogen. Here there is a removal of oxygen takes place. There is a no oxygen, so it is the removal of oxygen takes place. So this is the Clemmensen reduction reaction takes place. Then again Friedel-Crafts acylation takes place in presence of HF or polyphosphoric acid. Cyclization takes place and we are getting this compound. Again the reduction reaction takes place. If reduction reaction takes place, what happens? This oxygen is removed, so we are getting this compound. Okay, so this is the saturated part. So for to get the unsaturated, to get the double bond, we have to remove the hydrogen. So the dehydrogenation reaction takes place, and after the dehydrogenation reaction we are getting the naphthalene. So in this way the Howard reaction takes place, or Howard process of naphthalene synthesis takes place, and from benzene and acidic anhydride at the end we are getting the compound required, that is the naphthalene. This once again I will explain. So benzene acidic anhydride in presence of aluminum chloride, that is the Friedel-Crafts acylation, this product is formed. Again reduction reaction takes place. In the reduction reaction this double bond O is removed, so here there is absence of double bond. In the next reaction, in presence of HF or phosphoric acid, Friedel-Crafts acylation takes place. This carbon bind to this position and this hydroxy group is eliminated, so we are getting the this product. Again we have to remove this oxygen, so the reduction reaction takes place. In the reduction reaction this oxygen is removed, so here there is absence of oxygen, but the main problem here there is a absence of double bond. To get the double bond we have to remove the hydrogen, so the dehydrogenation reaction takes place, so removal of hydrogen takes place, and finally we are getting the required product, that is the naphthalene. So in this way the synthesis of naphthalene takes place by the Howard reaction. The last part of the naphthalene polynuclear hydrocarbon, that is the medical uses. The first one, it acts as antimicrobial. So antimicrobial means which are responsible to kill or stop the growth of the microbes. So that is the first use. Second was anti-inflammatory. It inhibits necrosis factor. Then third one, it acts as antiviral agent. Fourth one, it acts as anti-TB agent. Fifth one, they decreases the blood pressure, so they act as an antihypertensive agent, anti-diabetic. Then they are act as anti-neurodegenerative, antipsychotic, anticonvulsant, antidepressant, and anti-cancer. So in this way, actually this naphthalene is the basic nucleus which is utilized for the synthesis of drug, and these drugs may be having this type of activities. Most of the drugs they having the naphthalene as the lead molecule or the basic nucleus. With the different modification in the naphthalene, they are act as the different agents. Okay, so they may be the antimicrobial, anti-cancer, antidepressant, anticonvulsant, antipsychotic, anti-neurodegenerative, anti-diabetic, anti-hypertensive, anti-TB, antiviral, and anti-inflammatory. So naphthalene directly it will not act, but some modifications in the naphthalene takes place. That means the basic nucleus of all these agents is the naphthalene. This will act as all these activities. Okay, so this is about the first polynuclear hydrocarbon example naphthalene. Okay, remaining we will see in the next lecture.